Perfect square trinomials. Preparation for factoring special products. So we're going to take a look at a few perfect square trinomials and also a difference of squares in the last one to prepare for next lesson. So here's example number one. Is 25y squared minus 60y plus 144 a perfect square trinomial? Justify your answer. So I just want to go over what a perfect square trinomial is formula-wise. I'm not sure if you guys remember, but I'm going to try to highlight for you what a perfect square trinomial is. So going back to the days before, we had a plus b when we first learned about expanding. A plus b all squared. If you remember, if I were to FOIL that out or expand it, it was a squared, and then it was double ab. So you take a and b, multiply them together, and multiply it by 2 because it repeats itself. And then you multiply the last two b's, the b times b, which will give you b squared. And there's also a minus b all squared. So if you multiply two binomials that are identical, again, it's the first term you square, the last term you square, and you double the two terms on the inside. So b times negative b, a times negative b, which would be negative, doubling them. So negative 2ab will be your perfect square trinomial. So both these two expressions on the right-hand side are trinomials, perfect square trinomials. So we have to see if this is a perfect square trinomial. So what we want to take a look at is this is apparently, they're saying this is a squared and this is b squared. We got to find out what a is. So if they're claiming that's a squared, to find out what a is, we square root that and see if this is perfectly, if this is a perfect square root. Is it square rootable? So what's the square root of 25? It's going to be 5. Square root of y squared will be y. Square root of 144 will be 12. And if I multiply 2ab, so again, I want to see if it's a perfect square trinomial to see if that middle term is double a times b. So if I do 2 times a times b, 2 times a, which is 5y times b, which is 12, 5y times 12 will be 60y, which is kind of what we're looking for, but we're multiplying those two. So 2 times 60y will be 120y, which is not what they have. So if this was 120y, then it would be a perfect square trinomial, but it is not. So really what we're testing is 5y plus 12 and 5y plus 12. That's my a plus b. Right? If that's my a, which is 5y, that's my b, which is 12, so a plus b all squared. If I were to multiply this up, would that give me this? 5y times 5y would be 25y squared. 5y times 12 would be 60, and another 60 should give me 120, and 12 times 12 would give me the 144. So the outer terms work, but the middle terms do not. So right now, this is not a perfect square trinomial. Okay? Number 2, if the area of the box is given as follows, what is the length and width? So they're asking us what is this length and what is the width that goes here. So these are the areas, resulting areas of each individual box. So what times what? What could this and this be to give us x squared? Well, because it's a square, it's going to be x and x. So I know this is x here. What is this? X times something is going to give me this. Well, it's going to have to be 3, positive 3, because this is a positive here, so 3 times x gives me 3x. And over here, if I know this is x, what's this going to have to be? This is going to have to be 3. So 3 times x gives me 3x. And to finally double check, 3 times 3 gives me 9. So really what this is, again, this is considered a perfect square trinomial right here because we have x squared plus the total area for this is x squared plus 3x plus 3x plus 9. And if I were to, I am doubling it. See how I'm doubling this? I'm doubling this, x times 3, and multiplying a and b, and doubling it, which gives me 6x plus 9. Okay? So the length and width, therefore, x plus 3 is both length and width. Okay, the following represents a perfect square trinomial. What is the bottom right square? So again, this is going to have to be a perfect square trinomial. So we're trying to figure out what this is. So again, let's look at this. This is x So we need to find two numbers here, or two expressions here, that multiply to x squared. So that's going to be x and x. That's x, then what's this going to have to be? That's going to be minus 5. If this is negative 5x, and this is already multiplying x times something has given me negative 5x. We can divide. Negative 5x divided by x will give me negative 5. And so we do negative 5 times negative 5, which will give me positive 25 to get us that final portion right here. So really, the question was, if I were to put this all together, x squared minus 10x, this is a question that you'll be seeing next lesson. What is this going to have to be in order to produce a perfect square trinomial? Well, I know that I just have to take half of this, because this is a result of these two, which is two equal portions of the square, so that half of that's going to be negative 5x. And then, so negative 5, sorry, and then we square it in order to find out what that is. So that's going to be 25. Okay? So you half it and you square it to find out that final term to get that perfect square trinomial. Okay? It's going to be very important moving forward. The last example, what is the length and width if each of the givens are areas? Okay, so this one right here, we have to find the length and width again here. So this is going to be x and x to give us the x squared. And something, so 4x divided by x will give me 4. Negative 4x divided by x will give me negative 4. And 4 times negative 4 will give me negative 16. So we've solved this situation. This is x plus 4 is the length, and x minus 4 is the width. And what I want to do is I want to put this all together. So if I write an expression for the total area, so that's x squared plus 4x minus 16. This really is x squared minus 16. Again, this is a special situation called a difference of two perfect squares. So this is a difference of squares. I'm going to type it out. Difference of squares. Okay, very important definition. And the difference of squares is a resultant from a binomial that is the same absolute signs but different, same absolute number but different signs. Okay, so if I were to multiply this out, it becomes this. Okay, and if you understand the visual of this, that will help you with the next lesson when we go over how to factor perfect square trinomials and factoring difference of squares. Okay, if you have any problems, come see me during extra help, and we'll talk then. Take care.